Well, hello! So in this video we're talking about solving for x, so we're using equations some more, but in addition to that, pun intended, we're using segment addition, which is just a fancy way to say we're adding lines together. And so if we want to talk about segment addition intentionally first, it is that, hey, if we add FG together with GH together, well, adding those two line segments together gives us FH. Hopefully that's not too big of a surprise, but that's going to come invaluable when we talk about using our equations here. Looking at what we're given, we know that GH is equal to 16. Our goal is to solve for x, but then also find the length of the full line. And so let's apply it to just solving for x first. We know, because the problem gives it to us, very mystically, that GH is 2x plus 2. Well, we know that 2x plus 2 then, which is the distance of GH, is also, now notice how I'm speaking here, is also. Anytime I use the word is, that means equals. So 2x plus 2 is GH, and that is 16. Well, here we can solve for x. Subtract by 2 on both sides, ba-bam, ba-bam. We're looking at 2x is equal to 14. Divide by 2 on both sides. What we know then is that the value of x is equal to 7. This is the same x everywhere else in the problem. So we can apply that x into the other parts of the problem to solve for FH. So let's apply it in for FG. FG is 3x minus 1, which means we're looking at 3 times 7 minus 1, which is 21 minus 1. So FG is a distance of 20. Now keep in mind, GH is not 7. X was 7. So GH, what we were given, is 16. FG, what we just solved, is 20. That's what we're plugging into our problem here. FG is 20. GH is 16. When you add those together, we end up with 36. So FH is a distance of 36. Remember, a distance cannot be negative, and the reason why I'm not putting the line over FH is because we're talking about the numerical value, that distance, rather than the object itself. And so, I hope that helps. I hope that makes sense. Don't hesitate to email me if you have any questions.